So what happens when artificial intelligence stops just waiting around for you to type a question,
Right.
and instead it starts, quietly taking screenshots of your desktop, navigating your file system, and basically doing your administrative work while you sleep? Welcome to the deep dive.
Yeah, it's a huge shift.
Today, we are looking at this massive stack of technical specs, benchmark reports, and architecture documents from Anthropic. And the mission for you listening today is really to understand this monumental paradigm shift. We are moving away from chatbots that just, well, talk,
Yeah.
to these agentic teammates that actually do multi-step autonomous labor.
It's a profound transition. For the last few years, we've been operating in this prompt and response paradigm. You ask for a recipe, you get a recipe.
Exactly. You push a button, you get a thing.
Right. But the Anthropic Claude ecosystem we're unpacking today, it's designed to execute these verifiable work loops. It's the difference between an AI generating a text file of code and an AI spinning up a virtual environment, running that code, reading the error logs when it inevitably breaks, and, rewriting it until it functions perfectly.
And before we get into the heavy architecture of how those loops actually function, there is a historical nugget in these sources that I think uh, perfectly frames what Anthropic is trying to achieve.
The namesake.
Yeah, they didn't just pick the name Claude because it sounds friendly or whatever. It's a direct nod to Claude Elwood Shannon.
Which is such a deliberate choice for an AI company. I mean, Claude Shannon is universally recognized as the father of information theory.
Right.
His 1948 paper, A Mathematical Theory of Communication, is like the literal bedrock of digital processing. He's the reason we understand how to compress data and how to measure information in bits. So Anthropic naming their frontier models after him, it honors that profound mathematical legacy. They're dealing in the raw mathematics of information compression, which is essentially what a large language model is, but they've wrapped it in this highly approachable human-sounding persona.
It sets the tone perfectly. They're trying to bridge hardcore computational theory with a really accessible interface. Now, just to establish the baseline of the engine running this entire ecosystem for you guys, Claude operates on what Anthropic calls constitutional AI.
Right, the safety layer.
Exactly. Rather than relying solely on human reinforcement, the model is trained to evaluate its own outputs against a strict set of ethical principles, really prioritizing harmlessness. And it also boasts this massive 200,000 token context window.
Which is huge.
Yeah, to visualize that, you could drop several massive textbooks or an entire software repository right into its working memory simultaneously.
And that context window is powered by 3 distinct model families, depending on, the computational weight of the task.
Okay, break those down.
So you have Haiku, which is designed for sheer speed and low latency. Then you have the Sonnet family, specifically versions 4.5 and 4.7, which act as the balanced workhorses for complex everyday routing.
Right.
And then at the absolute frontier, you have Opus with version 4.7 handling the most demanding deep reasoning challenges.
But having a brilliant model is just the baseline, right? The real tension we found in these sources, and we're going to trace through this entire deep dive today, is the spectrum between absolute control and ultimate delegation.
Yeah, the autonomy question.
Exactly. When you give these models autonomy, how much of the wheel do you actually want them to take? To see this in its most extreme, high-stakes environment, we really need to look at how this ecosystem handles software engineering. So let's start with Claude Code.
Okay, so Claude Code is where you see the demand for absolute control. This is not a web interface. It is a terminal-based command line interface, or CLI.
Right, so it's in the developer's actual workspace.
Exactly. It lives locally in the developer's environment, and it's built around this gather, act, verify architecture.
And the benchmarks on this are just staggering. The reports show it hitting an 80.9% on the SWE bench verified test.
Yeah, which is massive.
It's the industry standard software engineering benchmark. And that score tops the raw models alone, and it beats out CLI prototypes of competitors like Cursor and Gemini. You can literally ask it to build a full user login system, and it will write the front end, build the back-end logic, set up database migrations, and write the automated tests all in a single pass.
It's wild.
Putting a 45-minute manual task into something that takes under 10 minutes. But I really want to dig into that architecture you mentioned. How is it actually doing that? Because it's not just typing blindly, right?
Oh, far from it. The gather, act, verify loop is what makes it an agent rather than just a generator. When you give Claude Code a complex command, it doesn't immediately start writing code. First, it enters the gather phase.
Okay.
It actively indexes the local repository, maintaining awareness of up to like 1 million lines of code. It reads the file structures, the dependencies, the existing logic.
So it's getting the lay of the land first.
Right. And once it holds that context, it uses an Opus 4 or Sonnet 4 model to reason through a plan, and then it acts, executing the new code inside sandboxed subprocesses.
The sandbox being crucial there, right. So it doesn't accidentally just nuke your operating system while it's experimenting.
Precisely.
Yeah.
But the real magic happens in the verify phase. Claude Code autonomously runs your testing suite or linters. If a test fails, the model doesn't just, throw up an error message to the human.
Right. It doesn't give up.
Exactly. It reads the stack trace, parses exactly why the logic failed, self-corrects the code, and loops back to the verify phase until the test actually passes.
Okay, I have to push back here for a second because handing over an autonomous loop that can edit 1 million lines of code sounds, frankly, terrifying.
It is a lot of power.
If it hallucinates a bad architectural decision, I mean, it could systematically rewrite my entire backend before I even realize what's happening. And the sources are very clear about the friction here. There is no reliable undo button.
Yeah, that's a big caveat.
Right. If it refactors a massive chunk of your architecture, you are the one stuck doing the forensic review of that code quality.
Which is exactly why that verify loop can quickly become a double-edged sword. If the AI gets stuck in a loop of failing and retrying, it's just burning tokens every single second.
Oh, wow. Yeah.
The technical specs note that for heavy users, token costs can rapidly escalate to anywhere between $5 and $30 a day. And it'll also constantly interrupt you with permission prompts, asking if it's allowed to run specific bash commands, which, fragments your focus.
So how do you rein that in? Like, how do you stop it from blindly rummaging through 1 million lines of code and burning $30 a day?
Well, Anthropic's structural answer to this is a philosophy they call developer sovereignty. They are explicitly designing for a user who demands total authority over the AI's context.
I want to translate that into how it actually works. Because instead of dropping the AI into a massive library and just telling it to go find a book, developer sovereignty relies on files specifically named CLAUDE.md.
Right, those markdown files.
Yeah. You, the developer, manually curate these files to act as this highly specific treasure map. You tell the AI exactly what directories it's allowed to see, what coding conventions it has to strictly follow, and what internal APIs it has access to.
That treasure map analogy is spot on. It severely limits the AI's search space. Yes, it requires a significant upfront investment of your time to map out those CLAUDE.md files at the project or organizational level, but it rewards that manual labor with blistering execution speed, massive token efficiency, and output that perfectly matches your exact specifications. Basically, you hold the reins.
But developer sovereignty sounds absolutely exhausting if you aren't an engineer. I mean, manually curating markdown files just to get an AI to help me with my daily admin work, that is a definition of friction.
Oh, absolutely.
If Claude Code represents the extreme end of absolute control, what exists for the average knowledge worker who just wants to delegate the busy work and, experience some ease of use?
And that tension brings us directly to the next major pillar of the ecosystem, Claudework, which is also referred to in the documentation as Cowork.
Okay.
If Claude Code is the hyper-fixated engineer requiring strict instructions, Cowork is the autonomous project manager designed for zero configuration.
And structurally, it lives in a completely different environment. It's not in your terminal. It's a dedicated desktop application.
Yeah.
But the architectural leap that really fascinated me in the sources is how it solves the biggest problem with standard AI chatbots, which is AI amnesia.
Yes. The worst part of web chats.
Right. With a normal web chat, the moment you close the browser tab, the AI forgets you exist. The entire context window resets.
And amnesia happens because standard web sessions are inherently stateless.
Yeah.
But Cowork is built on the concept of persistent state.
Persistent state.
Yeah. It operates inside a virtual machine or VM sandbox that runs locally on your desktop. This VM architecture isolates the AI from your core operating system for security, but crucially, it allows the AI to maintain the continuous state of a project across multiple days or even weeks.
So you don't have to constantly re-upload your core documents every morning.
Exactly. It remembers the context of what you were doing yesterday. And the loop it uses to execute tasks is entirely different from the engineer's approach. Instead of gather, act, verify, Cowork operates on a plan subtask execute loop.
Let's ground this for the listener. Imagine you drop a dense, 50-page financial report into Cowork. Your prompt is simply, analyze this report, build an Excel model based on the revenue projections, and draft a summary document for the board.
Okay, so under the hood, Cowork loads your project briefing from its persistent memory. Then the underlying Sonnet model generates a comprehensive plan, breaking that massive ambiguous goal into discrete subtasks.
Right.
It identifies that it needs to extract the data, format the spreadsheet, and draft the text. And because of the persistent architecture, it can route those subtasks to be executed in parallel.
And it doesn't need you to hold its hand while it does it. The sources detail that it utilizes 132 pre-built skills and integrations.
Yeah, that blew my mind.
Right. It reaches directly into Google Workspace, Notion, or your local file system to actually create the deliverables. The benchmark reports highlight this one scenario where Cowork organized 500 scattered files into a coherent directory structure in just 10 minutes.
A task that would take a human the better part of an entire workday. I mean, the time savings metrics point to users recovering like 6 to 8 hours a week of pure administrative friction.
But the trade-off for all that delegation is that you lose the absolute precision we saw in Claude Code.
Yeah, definitely.
The sources highlight several cons here. Because Cowork relies heavily on what Anthropic calls hidden processing, there are unclear capability limits when you hit edge cases.
Hidden processing is such a critical mechanism to understand here. To be zero configuration, Cowork actively hides the technical steps from you. For instance, if you ask it to summarize a dashboard you're looking at, it might take a screenshot of your screen in the background, parse the visual data, and map out the interface logic.
Without ever requiring you to manually hit print screen and upload an image yourself.
Exactly.
Which feels like magic. Until it hits an undocumented proprietary CRM system.
Right, the Salesforce problem.
Yeah, the sources specifically note there is no native CRM support yet. If it can't parse the visual logic of your weird internal Salesforce setup, it just fails. And because it's trying to do so much autonomously, there is a preview and approval process where it asks you to check its work before finalizing, which, can introduce some minor workflow friction.
You're making a philosophical trade. Cowork prioritizes accessibility over developer sovereignty. You trade token efficiency and granular control for massive administrative leverage. You're basically stepping out of the driver's seat and letting the AI navigate.
So we've mapped out pure logic with code and administrative delegation with Cowork. But what happens when the deliverable isn't a Python script or an Excel sheet? What happens when the work requires visual, spatial reasoning? How does this architecture handle design?
This is where we see Anthropic really trying to bridge that gap between control and delegation, using a tool called Claude Design. It operates on this chat-to-canvas workflow.
And the key mechanism making this possible is something called MCP, or the Model Context Protocol. The sources mention it powering the Figma integrations. Let's unpack what MCP actually is, because it is vital.
Okay, yeah.
You can think of MCP as a universal translator. Historically, if an AI wanted to manipulate a Figma file, it needed a highly specific, custom-built API connection.
Which is a nightmare to maintain.
Right. MCP acts as a standardized open protocol that lets Claude securely reach into a closed application, read the visual layers, understand the canvas state, and manipulate the elements directly.
It fundamentally changes how the AI interacts with graphical interfaces. With MCP in place, Claude Design utilizes a prompt reason prototype architecture, and it relies heavily on a hybrid Sonnet 4.5 model.
Why that specific model?
Well, Anthropic uses this specific model here because visual design requires a really delicate balance between fast, iterative generation and deep spatial reasoning.
So if you're a UX designer, you can import your company's existing design documents, or even just raw screenshots of a messy interface, and you prompt the AI, create a new user onboarding flow for mobile, and run an accessibility audit on the color contrast.
Yeah.
The AI reasons through the edge cases, like how a visually impaired user navigates the screen, applies your design system, and generates interactive prototypes on the canvas in minutes. And then you just iterate purely through conversation, like make the call to action more prominent or adjust the padding.
It's amazing. However, the sources do offer a very sharp reality check regarding its current capabilities.
Oh, absolutely.
It is currently in a preview stage, and it's explicitly characterized as being more reliable than creative.
Let's talk about that creative limitation because it leads into this concept of AI slop. If you go to Claude Design and ask it to invent a completely unique avant-garde aesthetic from scratch, it will struggle.
Yeah, it falls apart a bit.
AI slop, refers to that overly generic, hyper-smooth, derivative look that happens when an AI tries to be original without strict aesthetic constraints. It basically averages out human creativity into something entirely forgettable.
Which is exactly why Claude Design's reliance on strict, brand-consistent design systems is actually a massive feature for production environments, rather than a bug.
That makes sense.
It forces the model to stay within the guardrails of your company's specific fonts, colors, and button styles. It isn't trying to be an eccentric art director. It functions as an incredibly fast production assistant, executing the tedious logic of implementation like aligning 50 text boxes, so the human designer can focus entirely on the actual creative direction.
It's like the perfect middle ground between the strict rules of Claude Code and the hands-off delegation of Cowork. Now, if you are listening to this and mapping out how these agentic loops could reclaim 8 hours of your week, the immediate question is, how many disparate subscriptions do I need to piece this ecosystem together?
Well, the good news from the technical specs is that Anthropic has consolidated this into a unified pricing model. You aren't buying these tools piecemeal. You're essentially paying for different capacities of agentic bandwidth.
Okay, let's map how these tiers actually align with the tools. The free tier gets you basic, stateless chat. It is great for asking a quick question, but you get absolutely zero access to the specialized agentic tools. No CLI, no VM sandboxes, no MCP design integrations.
Right. The true gateway to the ecosystem is the Pro tier, which is priced at $20 a month or $200 if paid annually. This unlocks the Claude Code CLI, the Cowork workspaces, unlimited persistent projects, and the foundational elements of Claude design.
Okay.
It also provides roughly 5 times the usage capacity of the free tier.
But if you are leaning heavily into the developer sovereignty we talked about earlier, if you have Claude Code running constant gather, act, verify loops, parsing million-line repositories and burning through tokens, that pro capacity will run out quickly.
Very quick.
For that, they offer the Max 5X plan for $100 a month, or the Max 20X plan for $200 a month, which dramatically expands the token limits for those autonomous loops.
Finally, for organizations deploying these agents at scale, there are team tiers starting at $25 per seat. And this tier introduces a critical architectural safeguard, RBAC, or role-based access control.
And we should definitely explain why RBAC is absolutely essential when you have agents running loose. If Cowork is reaching into your file systems or Claude Code is executing scripts, you need to ensure the AI only has the permissions of the human operating it.
Exactly.
RBAC guarantees that an intern's AI agent cannot accidentally access confidential HR files or autonomously delete a production database simply because the agent didn't understand the organizational hierarchy.
It is the ultimate administrative guardrail. It's also worth noting that if you're a developer building your own custom applications using the Anthropic API, that compute is billed entirely separately by the token, independently of these desktop ecosystem subscriptions.
So, to synthesize this entire architectural shift for you, the era of typing a single prompt into a browser and hoping for a good paragraph is effectively ending.
It's over.
Anthropic's Claude ecosystem is built to give you specialized autonomous loops. You have the strict gather, act, verify precision of code, the persistent plan, subtask, execute delegation of Cowork, and the visual prompt reason prototype iteration of design.
The core takeaway from all these technical specs is that the nature of knowledge work is fundamentally changing. Whether you're managing a monolithic code base or just trying to organize hundreds of spreadsheets before a Friday deadline, the most valuable skill is no longer swinging the hammer yourself.
Right.
The new leverage is understanding which agentic loop to deploy, how to structure its environment, and how to govern its permissions.
It is entirely about mastering the spectrum between absolute control and absolute delegation. But that leaves us with a truly fascinating and slightly unsettling tension to chew on as we wrap up today. We explored how developer sovereignty forces you to map out every detail so you understand exactly how the AI operates. But we also saw how Cowork relies on hidden processing, taking screenshots, and navigating interfaces in the background to make your life utterly frictionless.
The trade-off between the friction of understanding and the ease of ignorance.
Exactly. As these agents become more sophisticated, and as they handle a larger percentage of our daily labor using hidden steps and autonomous subagents, what happens to our own fundamental understanding of the work?
That's the big question.
If we completely surrender precision and control in exchange for the ultimate convenience of zero configuration, do we slowly lose the ability to even spot the complex edge cases that the AI will inevitably miss? If we never see how the house is built, will we know when the foundation is cracking? Something to think about the next time you ask an invisible agent to quietly do your entire week's busy work while you step away from the keyboard.